Hello, my name is Jeff Crowns. I'm the Director of Technology at VoltServer. VoltServer is the industry leader in fault-managed power systems, and is redefining how power is delivered today in the most demanding applications. Our patented digital electricity technology provides intelligent, safe, and reliable power distribution that adapts to evolving infrastructure needs. This is an instructional video on how to unpack, organize, and install a VoltServer Digital Electricity fault-managed power system. Covered in this video will be shipping box contents, description of each part that's included, optional parts available, how to wire the equipment, and basic installation of a limited energy Class 4 fault-managed power system. We'll start today's video with the transmitter shelf, which is called the T4 AC 6K01, or commonly referred to as the Tetra 4 transmitter shelf. Inside the box is the transmitter shelf itself, along with some other parts. Most importantly, to start with, is the Quick Start Guide. The Quick Start Guide basically references all the information you need to know in order to install a system, including the specifications and how to install it. If you have questions, always refer to the Quick Start Guide. It'll be in every package. Also inside is a cable, which is basically the power cord that's going to connect us to the AC mains or UPS. Also included is the transmitter shelf itself, which will come in a plastic wrap package. And it's basically the transmitter shelf with a single power supply module. On the back side, this is where the AC circuits land. On the front side, this is where all the digital electricity circuits land. As you can see, it also has rack mount ears that come pre-installed, so it can be installed in a rack. There are some other parts in the box you want to watch for also. For example, the connectors that actually terminate on the front of the transmitter shelf. You just want to make sure that you see them and remove them because they are very important for the installation. These are the digital electricity modules or digital electricity connectors that plug into the front side of the shelf. Also included in this bag will be ground lugs for the backside, along with nuts to hold it on, and then also a couple connectors for input contact alarms. Next, I will look at the receiver options, and I'm going to start with a receiver called the RXDC HV4K01. It can source up to 350 volts DC and can be up to 1500 watts of power. So inside the box, like before, there's always a Quick Start Guide. Once again, if you have any questions, always reference the Quick Start Guide. And then also inside the box is the receiver itself, and taped to the top of the box is the connector. So always make sure that you look for this, that you don't yank the cardboard out and throw it away, because you do need this connector. Same thing as before, it comes in a sealed package, and the connector will seat directly into the receiver itself, which is where all the cable pairs land. On the front side of the receiver, you will see the input here, which is where the connector will fit in. And on the bottom side, there is outputs and ground. And if you look across it, it's positive, positive, negative, negative, and then the ground lugs. It also has a DIN rail mount on the back. There is an optional plate that can be put in here, so it could be surface mounted or it can go on a standard DIN rail. The next receiver we'll look at is the RXDC 56500. It can source up to 500 watts of 56 volts DC. It also has over voltage protection built into it, or surge protection, and I'll explain more on that later. In the box here, once again, Quick Start Guide. Can't stress this enough. Use this for reference as needed. Inside this box is the RX DC56 receiver, along with the connector. Once again, it's taped in the box, but make sure that you look for the connector itself. This one, the receiver itself is in plastic wrap again. And just like before, there is DIN rail mounts on the backside, so it can be mounted on a DIN rail, or there is an optional backer plate so it can be mounted directly. There is the connector that goes in the front for all the digital electricity inputs, and then there is outputs on the bottom. Positive, 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 negative, 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 and then a ground lug itself. That's the RX-DC 56500. The last receiver I'm going to unbox today is called the RX-DC 562K03. It is an outdoor rated receiver, so it is environmentally hardened. It has surge protection built into it and is great for outdoor locations. Once again, as before, quick start guide. Always reference it if you need any extra detail. Inside this receiver, and it is a little bigger because it is environmentally hardened, there is an accessory bag that you always want to keep track of. This is basically the inputs and outputs. This is the bulkhead connectors that have to be wired in, along with the ground lug, because you're going to want to ground this. The receiver itself looks like this. It has fins on it for heat dissipation, and on the bottom side there's bulkhead connectors. This is for the input digital electricity, and this is for the output of 56 volts power to power the device that needs to be powered. There also is a ground lug, which you would use the accessory kit ground lug to then ground that to a ground bar or a ground stake. That is the RX-DC 562K03. We'll start the installation process today at the transmitter shelf. This is the source of the power. This is where the AC mains drop is, or the UPS centrally located is. The transmitter shelf gets mounted to a 19-inch rack through the rack mount ears. Simple process to bolt it to the rack. On the front side, you can see there's a management port here. This is how, if you're going to manage the network, this is what you'll plug into. There is digital electricity output ports. Like I mentioned with the unboxing, these connectors plug right in to each one of the ports as needed. There is a power supply module in here. This is up to 3,000 watts right now, standard out of the box. If you want to add another power supply to bring it up to 6,000 watts, a power supply module can be slotted in. There is also an optional blank faceplate for the power module slot to cover that space. The power modules themselves are hot swappable, and to do so, there's a release pin that goes right in here that releases a lever. And once those levers are released, you have access to be able to pull the power supply module out. When you pop it back in, it slides, it seats, and then you lock them back in. Next, we'll mount the receiver and components at the remote location. Keep in mind that the transmitter shelf and the receiver cabinet could be up to 6,000 feet away. The power level and the number of pairs used for the design are specific to that project design. So the receiver itself is DIN rail mounted, so it will just plug onto a DIN rail connector and hang in place. The next thing you want to do is run the cable from the head end or transmitter shelf out to the remote location. So after you get your cable run within that pathway, you may opt to use a megger to validate the installation is in good condition. So that can be done by using a megohm reader. So you could check continuity from end to end on the circuit. And then you could also run over and do a megohm test. Now, if you do a megohm test, my recommendation is to follow the instructions from the megohm manufacturer, but that will validate that you have continuity and will validate that the installation is not damaged in the installation process. Now that the cable pair is tested good, cables can be terminated in the connector plug by stripping the end of the wires and actuating the levers on the connector plug itself. The levers come up, the cable pair goes in, and the levers snap down to hold it in place. Once that's completed, it can be plugged into the transmitter shelf, like that. I also terminated the cables going out to all the remote locations. And in this case, because I'm only using 2 pairs for each receiver, and it's a 4-pair cable, I terminated all the pairs on a terminal strip so that they can be used later. Basically, spare copper for use to add to the network later on. Next, we'll terminate the cable pairs on the receiver side. This connector is a little bit different than the other one. The releases are actually used to release the cable once it's been installed. So the way this works is you take a cable pair, you strip it, you pop it in, and you'll hear it click, and there'll be a little green tab that pops open. And that means that the cable is seated. So now both those pairs are seated, or both those conductors are seated, and to release them, you lift up on the release tab, which will release the pairs themselves. So to terminate, you install, you seat. To release the pair, if you want to later on, that's when you use the release clips. So now that you've seen how the connector works, I've terminated all 4 pairs into the connector to install it into the equipment. It will just plug in and snap into place. There is a little release pin on the top here that you want to make sure you depress when you release it to pull it out of the receiver. Now that the cable is terminated in the top, we're going to power the equipment. Grounding is very important, so we want to make sure we have a ground that goes to a proper grounding source. So ground gets terminated here, and then whatever you're powering comes in off the bottom of the outputs. In this case, we are powering a power supply that does a down convert from 350 volts DC to 56 volts D to then power whatever the load might be. The next receiver we'll be powering is the RX DC 56500. It is a 56 volts DC output up to 500 watts. In this case, we have wired it out to a hardened switch that's natively accepting 56 volts DC. So just like before, we terminated the cable pairs into the connector, plug it into the transmitter shelf on the input side. The switch is wired to the output side. This receiver has surge protection built into it, so grounding is very important. So make sure that there's ground connected and that it's going to a proper grounding source. Now that we have everything wired up, and just to explain what this setup is, I have a 4-pair cable going out to location number 1. I have a 4-pair cable going out to location number 2. I am only feeding each of those receivers with 2 channels on the transmitter shelf. All 4 cable pairs are terminated on the terminal block, but I'm only wiring out 2 to each receiver. So now it's time to apply power. Now that the grounds have been secured, the equipment has been wired, and the transmitter shelf has been wired. So I will apply power to the power supply module, and what you will see is the power supply module will kick on, the shelf will kick on, you'll see the digital electricity ports go active, and if you look at the receivers, you'll see channel 1 and channel 2 came up, and the output power is blinking. As soon as that goes solid, it will power the remote devices. So now all 4 channels are up and active. Location number 1 has the power supply module powered. Location number 2 has the switch powered. Everything is up and active. Another product we released recently was the RX AC 240 4K01. It puts out 240 volts at 3.8 kilowatts. It has plugs in the back side of it to plug into equipment, whether that be a switch or some other device. The really neat thing is it uses the same infrastructure for the other receivers. So I can unplug this receiver, plug it into this receiver, and it will come up in power. And now I have moved from 56 volts DC to 240 volts AC, but all the wiring stayed the same and the transmitter shelf stayed the same.